wanted to try out one of the SMD assembly services that some PCB manufacturers provide. So I designed this simple circuit in KiCad. In this video I'll go over the files I need to generate from KiCad after I've done the PCB design layout. And any things which I actually would update on this PCB design. And then at the end I'll go over the actual design of the circuit and how it works. So I designed this kind of credit card sized electronic business card just as a test for the SMD service. And they laid out the SMD components really well. If I get a bit closer and hopefully focus in, they did a really good job on laying out the circuit onto the PCB. It would take ages to lay out 64 LEDs like I've got here. Then it's a very simple PIC microcontroller with shift registers at the bottom. So there's a few things which I would do slightly different on this design if I were to do it again. One of them is when I selected the switch, it's quite a high switch. You can get lower profile switches. I would have chosen a lower profile switch. And I would have put a little hole in the top so I could connect it to a ribbon around your neck as well. So not just a PCB business card, but it could be like a tag as well that you wear around your neck. Also on this side, I had to go at PCB art in this bottom corner, which this is the very first effort I had, but I now know from doing this effort how I could have made it a lot better. So hopefully next time I send off for some PCBs, I'll try out a slightly different design there and see how it goes. I had ICSP tags here, but I chose a component too low. That should have just been a 2.54 pitch connector there, and so I'm not quite sure how I managed to select that, but I selected the wrong one there, so I had to use a slightly different way of programming it once I got the PCBs back. And also around the battery holes, I left a little. I think it's good to leave a little bit of a gap just in case the batteries that you get are slightly oversized, because you never know with cheap manufacturers and stuff. But really, it could have been about 1 millimeter less on the size of the diameter of the actual holes themselves. I've got two 1K resistors there, which I'm using for the line in from the ICSP, and those values are a bit too high, I found out, which I should have really got in testing, but I never picked that up. But apart from that, the circuit works, and the design all assembled fine, and the compactness you can get of these SMD components through this PCB manufacturer service and SMD assembly is really good as well. So like I say, the ICS in the InCircuit Programming pins that I put on the back, or the pads for InCircuit Programming, I used a far too small pitch connector to do that. But lucky enough, I already had this 8-pin dual inline socket to this clamp, which fits around an 8-pin SOIC surface mount component. So I can actually plug this on top of the surface mount PIC, plug this into my programmer, and it programs fine. So I've got this wired up to my PIC programmer, and I've got the connector over my microcontroller. I shouldn't really be doing it with the batteries installed in here, but I'll do an arrays and then a program. So start off with doing the arrays. And it's interesting how the LEDs make funny patterns while I'm actually erasing and programming. Now I'll start the programming because I'm sharing the InCircuit Programming pins with the actual pins which control the shift registers, and so it makes nice little patterns while I'm programming this. And when it's finished programming, you'll come up with a little pattern where the batteries the programmer turns off, the batteries take over, and you'll see the reset pattern, which is to that pattern there. So that shows it's actually programmed. So if I take this off now, it's upside down, but if I click on start, the message should start coming across the screen. When I did the PCB design and layout, I didn't just do a surface mount layout and then send it straight off to be manufactured, because I wanted to make sure that it was going to work. So I made this through-hole version with homemade PCB, because all the components actually have 100% equivalent in through-hole components I've used as they have on surface mount components. So I could do this with and know if it works here, then it should work on the assembly I got back. And so lucky enough that was the case. So if I plug in a lithium-ion battery into this test circuit, and you'll see the boot symbols come up, and then it goes to sleep. And then if I press the button, it'll display a message that I've programmed into it. And I find that essential to make one at home, make sure it works first, and then send off. Also, it improves your programming as well. So what I could do is I could actually write a program for this, make sure the program worked fully before I sent off for the design, because it's always possible that when you do design and you start programming it, you realise that actually the design doesn't quite work with the program you want to write. So it's essential probably to get the program written before you send off for the actual surface mount design, if it's a microcontroller or computer type thing. Yeah, so this is going to be a bit awkward to demonstrate, but I put because I had a GPIO pin left over, so I put it out on a couple of pads called AUX. I wasn't sure what I was going to do with the AUX pads when I actually produced it, but after doing some programming, I decided to make it just a UART input so that I can use this USB to UART device in my computer, and just go into a terminal and use these two connectors to reprogram the message on the device. So if I press the button at the minute, it has a message called test, just that says test, and this is the awkward bit because I'm doing this over a camera, so I need to hold these onto the pads, and you'll see as I type, the LEDs light up to show which character I've typed in. So JA. So I'm going to put my name in. So I put my name in, and then I can just wait for that LED to go out, and that shows that it should be programmed, hopefully. Then when I press the button, it should hopefully have my name in now. So that was quite convenient. I put those pads on there so that I can reprogram the message anytime I want, just using the UART cable, but without having to reprogram the actual PIC device itself. So the circuit's a very simple circuit. So just quickly, I've got over here pads for connecting the batteries up, which I lay out as pads on the actual board itself. I've got a connector for InCircuit Programming here, which goes to the appropriate pins on the microcontroller. Got the aux pad here, which goes to the GPIO which I had left over, which was GP5. I've got the switch here, which goes to the GP3, because that's always just an input, so I usually sling a switch on that one. But the actual circuit itself, so I've got two shift registers, one there and one there, and the shift registers, it shifts out of one and into the other, so it's just one kind of 16-bit shift register in 2 8s in series, and one of the shift registers controls the rows, and one controls the columns of the LEDs over here, which is an 8x8 grid, so 64 LEDs in total. So all I do in the program is shift data into the shift registers to select which row and which column, and I just scan the LEDs and turn on whichever ones I want to display the message scrolling. So in KiCad, you've got your surface mount design. I then click on the plot option, and I select these files, so front copper, back copper, front paste and back paste, because we're going to do a SMD assembly, so you need the solder paste on there. Front silk screen, back silk screen, front mask and back mask. I also do edge cuts. So these are all Gerber files. And then if you go into File, then on that menu there's Fabrication Options, Footprint Position POS file. This is what generates the pick and place position files. You definitely need separate files for back and front. I output in millimeters and generate a CSV file. And then once you generate that file, that generates the front and back position files. But in the manufacturing process that the JLC PCB currently only can do one side or the other. So I've put all my components on the front side, and I just, although I provide them with both front and back position files, I only populate the front one, and you select which one you want to use when you actually go through the options for manufacture. And then the bill of material file is in the same fabrication outputs under the file menu, then BOM file, and I just use that to generate the comma separated file for the bill of materials. I think there might be other ways of generating the position files and bill of materials files in KiCad, but these ones I just use because it's nice and simple. I rearranged the column orders and renamed the columns myself. So these are the files which I actually send out to the PCB manufacturer. So these are all generated from KiCad. So the bottom copper Gerber files, bottom mask, bottom paste, bottom silkscreen, the edge cuts, front copper, front mask, front paste, front silkscreen, and then the drill files. I say all the drill files which are generated from KiCad I just send out in the zip file, because you have to zip them all up into a single file. Then the bill of materials, the bottom pick and place file for it, which is a comma separated file. The drill report, like I say, these drill files, they're just some of the drill files which are generated, and then the top pick and place file. So the bill of materials and the pick and place files, you need to modify those slightly to be in a particular format. So this is the bill of materials file, and you just need to arrange the columns which are output, so that and give these column headers. So these column headers need to be specifically placed in there, and the columns need to be in this order. So comment, then designator, then footprint, and then the part number you want to choose. Now I used JLC PCB, and so they have a place where you can search what parts they have for their pick and place machines, and you just go through your part list and you pick out their part numbers for each of the columns, so that it automatically can fill those in. And then in the position files, so this is for the pick and place machines. This is output from KiCad as well. Again, the column headers are mandatory, so you have to name them as they are here. It's probably worth checking on the manufacturer's site itself. I mean, maybe other manufacturers might do things differently, but for JLC PCB, this is the way it currently is. It might be worth checking, making sure the column headers are correct as of the date that you actually submit yours, because they may change from time to time. And for the pick and place machines, you have designator, the value, package, and then the X position, Y position, the rotation of the component. Now, at the time I made this, they don't always get it correct. When you upload the file, JLC PCB don't always get the rotation correct. Now I always go back and I correct the rotation in this file and re-upload the file so the JLC PCB looks right on their preview. But on their actual upload place, they say, oh, if it's not right, you can leave it to us, because we always go through and we always check the position and the rotation anyway. But I think it's probably best to get the rotation right anyway, and in the uploaded file. It takes a while because you have to go back a couple of times and just re-upload the file and make sure that all the components are in the correct orientation.